Unit 6B, Lesson 2. In this lesson, we're going to focus on formulas for calculating the union of sets, the intersection, the complement, and also at the end of the lesson, we're going to talk about conditional probabilities. First, we're going to discuss the formulas for the union, which means or. So if we have the probability of A or B, if those events are mutually exclusive, meaning they have no overlap in their sets, then all we're going to do is add those two probabilities together. If the events aren't mutually exclusive, meaning they have some overlap in their sets, then the probability of calculating A or B is going to be the probability of A plus the probability of B minus the probability of the intersection of A and B. The formula for the complement of an event is pretty straightforward. So if we want to calculate the probability of the complement of A, that is going to be equal to 1 minus the probability of event A. A total probability is equal to 1. So if we take 1 minus the probability of A, that has to leave us with what's not in A, which represents the complement of the event. Before we move on, there's one thing I forgot to mention when referring to the union of two events. When using these formulas, sometimes this is referred to as the addition rule because in the formula, we're adding the probabilities for event A and B together. Next, we're going to go through the formulas for the intersection, which means and. So the probability of both A and B happening, if A and B are independent events, then the probability of A and B is equal to the probability of A times the probability of B. If A and B are not independent events, then the probability of A intersect B is equal to the probability of A times the probability of B given A. When we see this bar, when dealing with probabilities, that refers to given. So the probability of event B happening given that event A has happened. Sometimes the formulas for the intersection of two events is referred to as the multiplication rule because when we look at the formulas, we're multiplying those two probabilities together. The last thing we have to talk about are the formulas for conditional probabilities. So the probability of event A given event B is going to be equal to the probability of the intersection of events A and B divided by the probability of B. If we want to calculate the probability of event B given A, very similar, and the numerator is going to be the probability of the intersection of events A and B. The difference is going to be now we're going to divide by the probability of event A. If you look at these formulas, they're going to be very similar to what we talked about on the previous slide when dealing with the intersections of events A and B. All we would have to do is multiply the probability of event B to the other side of the equation, and now we would have our formula for the intersection of A and B. One thing we do need to be aware of in this case is that the probability of event B cannot be equal to 0 because it's in the denominator of the fraction. Normally, we're not going to be dealing with a probability that's equal to 0. It just doesn't make sense in terms of finding the problem, but we do have to be aware of that incident. In this lesson, we just went through the formulas for the intersections, the unions, and then conditional probabilities. Now I want you to watch the other lesson I found that's going to go through some examples incorporating these formulas.